Students, good morning. Today I am going to discuss about the differential changes in entropy. This video class is useful to estimate the total differential changes in entropy for a simple compressible fluid or a compressible system. Simple compressible fluid or a compressible system. Before entering into this discussion, some of the information from my previous videos are represented here. One is fundamental property relation, second one is Maxwell's relations, another one is volume expansivity, isothermal compressibility, and the differential changes in internal energy as well as differential changes in enthalpy. These informations are much more useful or helpful to us in establishing the derivation or expressing a derivation to find the total differential changes in entropy of the system. For a pure homogeneous fluid, the thermodynamic state of the system can be expressed by using the thermodynamic properties temperature, volume, pressure. Among the three, you have to choose any two. It is easy to express the thermodynamic state of the system. In that sense, let us consider the entropy. First, it is a function of temperature and volume. Let us consider entropy S is equal to the function of temperature and pressure. In order to estimate the total differential change, the total differential change is ds is equal to dou s by dou t at constant pressure into dt plus dou s by dou p at constant temperature into dp. This is the equation established by assuming entropy is a function of temperature and pressure. It gives changes in entropy, total differential changes in entropy, dou s by dou t at constant pressure into dt. This is expressed from differential changes in enthalpy H. Hence, this equation becomes Cp into dt plus dou s by dou p at constant temperature. Dou s by dou p at constant temperature is equal to dou v by dou t at constant pressure minus sign. So this equation becomes minus dou v by dou t at constant pressure into dp. Clear? This is one form of important equation used to estimate the total differential changes in entropy. Next, again I am going to assume that entropy is a function of temperature and volume. Temperature and volume. The total differential change. Total differential change is ds is equal to dou s by dou t at constant volume into dt plus dou s by dou v at constant temperature into dv. Dou s by dou t at constant volume. Dou s by dou t at constant volume is obtained from differential changes in internal energy. Hence, this equation becomes Cv by T into dt plus dou s by dou v at constant temperature. Dou s by dou v at constant temperature is equal to dou p by dou t at constant volume. Into dv. Clear? Next, in this equation, the dou p by dou t at constant value, this partial derivative term can be expressed in terms of compressibility beta and volume expansivity gamma. Isothermal volume expansivity beta and isothermal compressibility gamma. For that, let us consider the volume of the system is a function of temperature and pressure. Volume of the system is a function of temperature and pressure. On total differentiation or total differential change, dV is equal to dou V by dou T at constant pressure into dT plus dou V by dou P at constant temperature into dT. In this case, dou P by dou T at constant volume. Volume is constant. For constant volume process, dV is equal to 0. Changes in volume is equal to 0. Hence, this equation becomes dou V by dou T at constant pressure into dT is equal to minus of dou V by dou P into T at constant temperature into dV. I am in need of dou P by dou T at constant volume. Dou P by dou T. So dou P by dou T at constant volume is equal to dou P by dou T. Hence, dou V by dou T at constant pressure divided by dou V by dou P at constant temperature minus sign. So this equation becomes dou V by dou T at constant pressure. Dou V by dou T at constant pressure is equal to beta into V divided by dou V by dou P at constant temperature. Dou V by dou P at constant temperature is equal to gamma into V, alpha into V minus sign. Hence, this equation becomes total differential changes in entropy Ts is equal to Cv by T into dt minus already we have one minus plus minus of beta V divided by alpha V into dV. These expressions are much more helpful to us to find the total differential changes in entropy of a simple compressible fluid or a substance. Thank you. Correction: ds dou S by dou T at constant pressure. Dou S by dou T at constant pressure is Cp by T. Cp by T. A small correction.